ability to process and analyze digital images has become more crucial as their use has increased. The capability to automatically recognize and classify images allow programmers to create models with various uses, including self-driving cars and facial recognition, among many others. Because deep learning makes it possible to create highly accurate models, it has completely changed how image classification is done. The relevant features in an image can be easily learned and extracted using a deep learning algorithm. Overall, deep learning-based image classification has grown to be a hugely popular framework because of its precision, adaptability, and because it has the potential to build extremely powerful models for various applications. Hey everyone, you're watching Simplilearn, and in today's video, we're going to be learning all about Pytorch and how to build a neural network using Pytorch. If you love watching videos like this, do hit the subscribe button to never miss any updates from Simplilearn. So now, without any further delay, let's start with the Pytorch installation. If you want to become a machine learning expert, consider Caltech postgraduate program in AI and machine learning by Simplilearn and master those necessary skills. Check out the link in the description for more details. But before we dive into the installation process directly, let me explain you what is Pytorch and why Pytorch is a popular machine learning framework. Well, Pytorch is a machine learning framework used for image classification and neural network processing. It is a Pytorch-based open-source machine learning implementation based on the Torch library. It is the most popular AI library. It is the most popular AI library among industry and academic researchers worldwide. It increases the machine learning framework's adaptability. It will also offer high implementation speed for deep neural networks. Therefore, a well-liked machine learning framework is Pytorch because of its ease of use, adaptability, and powerful capability. It also provides a wide set of tools and libraries for building machine learning models, and additionally, Pytorch enables the modification of computational graphs, making it simple to test out various models and architectures, as well as to debug and improve existing models. So now to install Pytorch, first make sure that Python is installed in your system. And to install Python for programming, visit the link python.org. So you can just type Python. So you can click on the first link. Go to downloads from the menu bar and click on Python.11.2 to download for Windows. So just click Run Python and install it. So once installing Python, check if it is successfully installed using the following command in the command prompt. So to check, just open command prompt. Hope my screen is visible. So here you can just type Python __ version and it must display Python version. And if you get the Python version, then we are good to go. The next step is Anaconda installation. So open new tab, type Anaconda. Okay. So to install Anaconda, visit the link anaconda.com. And here you can just scroll down and you can see here green button, download for Windows. Just click. So as you can see, it will be downloaded here. So once the Anaconda is downloaded, open the file and click on Next. Okay, so click on Next. And then next, click on I agree. Select Just Me Recommended. And click on Next. Next, choose the installation location. Click on Next. And then just click on Install, or you can select Add Anaconda 3 to my path environment variable. Yes, this is important. And then click on Install. So once you click on Install, it will be installed successfully. I'm not going to install since I have already installed in my system. And to check whether the Anaconda has been installed successfully, check Anaconda version in the command prompt. With the command like conda __ version. You can also check in Anaconda prompt. So first let's check Python version. Version. Okay, so it has displayed the counter version, that is 23.1.0. So we have now installed Anaconda and use the command prompt to check its version. And once you get the Conda version, the following step is to install Pytorch. For that, open the new tab, and to install Pytorch, just type here Pytorch and click on this first link, that is pytorch.org, and here just scroll down, and here you can see this. So select according to our system's requirement. So suppose you want to select this Pytorch build, so click on stable, and then your OS, so as per your system, if it is Linux or Macs or Windows, so this is Windows, so I'll click on Windows, and then package, go with the Conda or pip, so I'll go with the Conda, and then language Python, and compute platform. So if your system is having GPU, then you can go with CUDA, else you can click on CPU. Okay, and whatever command here you got, run this command on the prompt. So you can just copy this. You can just copy and paste it here. So I have already installed it. I'll just show you how to paste. Yeah, you can paste and give enter. So all the required files will be downloaded. And to check whether the Pytorch has been installed successfully, run the following command, that is conda list _f Pytorch and give enter. So here, if you get the Pytorch version after running the command, that means Pytorch is successfully running, and you got here Pytorch name, version, build and channel. So now we have learned to install Python and Pytorch. Following this, let's build a neural network for beginners. So hope you're clear with how to install Python, Anaconda, Pytorch, and now we are good to get started with building neural network. So using Fashion MNIST dataset, we are going to create a convolutional neural network to predict dataset classes. You may be wondering why we are using the MNIST dataset rather than any other. So let me tell you that the MNIST dataset is the first one on which the researchers attempt to develop and test deep learning models for image classification tasks using CNN. The Fashion MNIST dataset can be used to train image classification models and has grown in popularity as a way to evaluate how well machine learning algorithms and models perform. And the Fashion MNIST dataset is commonly used in CNN or convolutional neural network. It is a type of deep neural network that performs image classification and processing tasks. It consists of several convolutional layers that are designed to automatically extract useful information features from the input image data. And the first step is to import all necessary libraries. So let's input them one by one. Import NumPy as NP, then import Pandas as PD, import matplotlib dot pyplot as plt. So this is to show the image. Next, import torch vision. First let's import torch and then import torch vision. Torch.nn as nn. This is from torch.autograde import variable. Torch vision import torch vision dot transforms as transforms from torch dot utils dot data import dataset comma data loader from sklearn dot metrics import confusion matrix. Okay, once we are done, just execute this. As you can see, it's running. So wait for it. Okay. So next step, device configuration. So use the GPU for the computation if available. Otherwise, you can go with the CPU. So to check that, you can just type device is equal to torch dot device if available CUDA if torch CUDA dot is available. Else go with the CPU. So let me give this in the double quotes. Okay, let's enter. So next, using the pandas library, we will now read the two CSV files, that is fashion MNIST train.csv and fashion MNIST test.csv, and then store the data in the train CSV and test CSV respectively. So for that, you can type train underscore CSV is equal to pandas, that is pd dot read underscore CSV, and so that you can give fashion MNIST train dot CSV, and same goes with the test underscore CSV is equal to pd dot read underscore CSV, give fashion MNIST test dot CSV. Okay. Next type train underscore CSV. It will display the train CSV files. So to display the files, train underscore CSV. And same goes with the test underscore CSV. Okay, and you got the output. So now let me brief you on the fashion MNIST dataset. So it is a collection of images of clothing items such as dresses, coats, t-shirt, etc. So the fashion MNIST dataset of grayscale images is divided into test and train dataset, where the train dataset consists of 60,000 examples and test dataset consists of 10,000 examples. Along with that, the dataset consists of 10 classes representing different type of clothing items like t-shirt, tops, trousers, pullovers, dresses, coats, sandals, shirts, sneakers, bags, and ankle boots, in which each grayscale image is of size 28 into 28 pixels, a total of 784 pixels. So here you can see in train dataset we have 60,000 and in test dataset we have 10,000 examples. So as shown on the screen, this is what each pixel has a single pixel value that indicates the lightness or darkness of the each pixel value, with higher number indicating darker pixel. Okay. So the training and test dataset consists of 785 columns. Here you can see 785 columns. So with the integer for the this pixel value ranging from 0 to 255. So the class label make up the first column. So this is the class label, so which represents the piece of clothing, and the remaining column contain the pixel values for the associated image. So I hope it's clear. You can see here we have 10,000 rows into 785 columns, And here we have 60,000 rows into 785 columns. So in next step, create a user-defined class with the name fashion dataset for creating a dataset. So class fashion dataset, and inside give dataset. Next, create a method to initialize the variables. So let's give def __ init self comma data comma transform is equal to none. So initially it's none. Then self dot fashion MNIST is equal to list of data dot values. Self dot transform is equal to transform. Next, let's give label and images. And then using for I in self dot fashion underscore MNIST label dot append of I of 0. Then same for image dot append I of 1. Here, this iterates over a dataset called fashion MNIST and appends the labels and images to two separate lists called label and image respectively. And next, you can give self dot labels is equal to np, that is numpy dot as arrays label. Self dot images is equal to mp dot as array of image dot, we are reshaping the image, reshape -1 28 by 28 comma 1 dot as type float. So here dimension of image is given, that is 28 by 28, and whereas 28 and 28 is height and width, and the color channel is 1. So here we got the color channel as well as the size of the image. So we are going to reshape the size of the image. And then next create a get item method to return the images and labels. Def underscore get item self comma index. Then label is equal to self dot labels of index. Then image is equal to self dot image so images of index. Then if self dot transform is not done, is not none, image is equal to self dot transform image. It should return image and comma label. So, and then create the length method to return the number of items in a dataset. So once it returns the image and labels, next create the length method. So give def underscore underscore length of self, return length of self dot image, image's length. So let's execute it. Then load the dataset. So for that, train data is equal to transform. Okay, it's a fashion dataset. Train, comma, transform is equal to transforms dot compose of transforms dot to tensor. And same with the test data. Test data is equal to fashion data set. Give test and with the same, so you can just copy the same thing here. Give comma and paste it here. And with that, let's give train loader is equal to data loader of train data, comma, batch size is equal to 100. And next test loader is equal to data loader train data, comma, batch size is equal to 100. So here the transform argument here, as you can see, the transform argument is used to apply transformation to the input data, and then the train loader and test loader are data loader objects that are used to load data in batches during training and testing. So whereas this batch size specifies the number of samples to load in each batch. So here I guess we have given train underscore CSV, and here also test underscore CSV. So now let's run it. And next download the dataset from fashion MNIST. So train underscore set, we are downloading the dataset dot vision dot datasets dot fashion MNIST double colon dot, this is the root path folder data, comma, download is equal to true, comma, train is equal to false, comma, transform is equal to transforms dot compose transforms dot to tensor. So let's copy the whole sentence here, copy the whole code, and we'll do the same for test set. So test data set. So here maybe you can remove this. Yes. And here we have test data set. So we have given test data and then torchvision.dataset.fashion MNIST data download true, and here train false, transform is equal to transforms.compose. Okay, let's give enter. True is not defined. Okay, let's give it in caps. Compose. So here we had made maybe spelling mistake. Okay, here give S, and now let's run it. Yes, okay. All right. Next, let's give a train loader. Train loader is equal to torch dot utils dot data loader train data, comma, batch size is equal to 100. Same thing, let's do it for the test loader as well. Paste it and change this to test loader is equal to torch utils dot data loader, and here let's give test data, and then batch size is equal to 100. Run it. Next, give the function def output underscore label of label output mapping is equal to, enter all the labels here from 0 to 9. So totally we have 10. So we are giving from index 0 to till 9. So in the place of 0, give t-shirt first. You can give anything. Let me give t-shirt or top, comma, 1 trouser, comma, in the place of 2, give pullover, three, let's give dress, fourth coat, fifth, let's give sandals, then sixth, shirt, comma, 7, sneakers, after sneaker let's give bag, and ninth, ankle boots. So let's make it capital P. All right, and then give input is equal to label dot item of if type label is equal to torch dot tensor else label. Then return output mapping of input. Okay. So this function converts the label that is inputted into a text label that corresponding to it, and either a tensor or a scalar label may be used as an input parameter. And then we are giving a is equal to next iter train loader of 0 dot size. So here it must give the output of tensor size. So let's give. So we got tensor dot size 100, 1, 28, 28. And then let's print the length of the train data. So for that, let's give length of train data, and it is 60,000. So then let's display the image using the method imShow. So for that, let's give image comma label is equal to next of iter train set, then plt plot dot imShow method image dot color mapping is equal to gray. Print label. So let's run it. And here, as I discussed before, the image dimension is given 28 by 28 and the color is gray. So here you can see 28 by 28. So if you want to try different color, maybe you can go with autumn. Here I can type AUTUMN_R. Let's check which color. So yeah, this color. And you can also go with another color. You can just type VIRIDIS. So yeah. So for now, let's give gray and let's run it. Okay. Next, print the torch size. So for that, give demo loader is equal to torch dot utils dot data dot data loader train underscore set comma batch size is equal to 10. Batch equal to next iter demo loader images comma labels is equal to batch print type of image images, comma, type of labels, again print images dot shape, comma, labels dot shape. So here we got torch size. Okay, here let's give batch size to be 100. Also, yeah. So you got it. And then the code prints the type and the shape of the image and label tensor. And next, let's print the image. Not one image, let's print all the images. So for that, you can give grade is equal to torch vision dot utils dot make grid images, comma, n rows is equal to 10. Then plot dot figure size, let's give 15, 20. Then plot using mshow method, in that np dot transpose read, comma, 1, 2, 0. Let's print the labels, end is equal to space. Using for I, comma, labels in enumerate labels. So finally print output underscore label of labels end is equal to comma. So here I remove this and give it here. So now let's run it. Okay, here let's give it 10. Run it. Also run this piece of code. Yeah. So here you got all the 10 rows. So here you have ankle boot, t-shirt, top, t-shirt or top, and then we have again top, dress, t-shirt, pullover, sneaker, pullover, sandal, and sandal. So here you can change the size of the figure. Maybe if you want, you can give 5 by 10. So it will become smaller in size. Yeah. So let's keep it 15 by 20 and let's run it. So every training and testing example is given one of the labels listed below. It can be any one from here. So next, make a model class that inherits the Pytorch nn.module class. For that, give class fashion cnn of nn.module next def init of self super fashion cnn comma self dot init method. Then give self dot layer 1 is equal to nn dot sequential nn dot convolutional 2D in channel. In channels is equal to 1, comma, out channels is equal to 32, comma, kernel size, let's keep it 3, and then padding is equal to 1. And then batch null p of 32, comma, nn dot relu function. This is activation function, and then we have nn dot max pool (2D) of kernel size is equal to 2, comma, stride is equal to 2. And then let's give self dot layer 2 equal to nn dot sequential of nn dot convo. Let's keep it capital C here. In dot channels is equal to 32, comma, output channels is equal to 64, kernel size is equal to 3, comma, nn batch norm 2D of 64, comma, nn dot relu, this is the activation function, nn dot max pool D of 2. Make sure you're giving the correct spacing, because spacing is very important when you're working in Jupyter Notebook. So let's give underscore here. So here, this piece of code defines a convolutional neural network, that is CNN, with two convolutional layers followed by a batch normalization. Here we have a batch normalization. So the first convolutional layer, that is here, this one is the first convolutional layer. So here it takes a grayscale image with one input channel. Here we have the one input channel and applies 32 filters of size 3 by 3 with a padding of 1. So keep the input image spatial dimension. So finally a max pooling layer. So here we have also a max pooling layer with a kernel size of 2 by 2 and this stride is 2. This is applied to reduce the spatial resolution of the output by half, thus reducing the number of parameters in the subsequential layers. So here in the second layer, so this is a second convolutional layer. Here it takes the output. So what happened here is takes the output of the first layer as input and applies 64 filters of the size 3 by 3 and there are no padding. So in short, I must say that it makes a model class that inherits the Pytorch NN module. So this is the NN module class. So it is actually a superclass for all neural networks. So in our case, we have taken the fashion CNN. So our neural network is composed of the following two layers. So this is one layer and this is the second layer. So there are two subsequential layers, each of which is having the following layers. A convolutional layer with a kernel, again I'm repeating, the kernel of 3 by 3 and padding is 1 in the first layer and there is no padding in the second layer. So padding is 0 in the second layer. And there is a one stride is shaped by both the layers. And we have the RELU as the activation function. And then we have a max pooling layer with kernel size 2 by 2 and stride is 2. And then also a layer for batch normalization. I hope it's clear. So next, type self dot fc1 is equal to nn dot linear in features is equal to 64 into 6 into 6 comma out feature equal to 600. Then self drop is equal to nn dot drop out 2D 0.25. Then self dot fc2 is equal to nn dot in features is equal to 600 out feature is equal to 120. Then again self dot fc3 is equal to nn dot linear in feature is equal to 120 comma out feature is equal to 10. Then we have def forward method self comma x out is equal to self dot layer 1 of x, then out is equal to self dot layer 2 out, then out is equal to out dot view out size of 0, comma -1. Then out is equal to self dot fc1 out, and then out is equal to self of drop, so here it should be out self dot drop. Then out is equal to self dot fc2 of out equal to self dot fc3 of out. Return out. So here, this code defines a neural network model with 3 fully connected layers. These are the fully connected layers, 3, FC1, FC2 and FC3, and 2 convolutional layers, that is layer 1 and layer 2. Here we have layer 1 and layer 2. And the forward method specifies the order in which the input X is passed through the layers of the network. Here we have the input X. So the input X is first passed to the layer 1 and then layer 2. After passing through the convolutional layers, the output is flattened using the view method. This is the view method here. This is to be compatible with the fully connected layers. And finally, the output of FC2 is obtained and then passed through the FC3 to obtain the final output. So we have run this code. Next, create an instance of the fashion CNN model. So let's give it here itself. Model. Equal to fashion CNN model dot to device error is equal to NN dot cross entropy loss, and then learning underscore rate is equal to 0.001, and then optimizer is equal to optim dot Adam model dot parameters of LR is equal to rate, then print model. So here we got the output. And next, let's give number of epoch is equal to 5. So an epoch means training the neural network with all the training data for once. So we have given here 5, and then count is equal to 0, then loss, then we have iteration list, next accuracy list. We also take prediction list. Followed by labels. For Pytorch in range of Pytorch. For images, comma, labels in train loader. Images, comma, labels in train loader. Sorry, images, comma, labels dot images. Let's keep equal to images dot to device. We are moving it to the device. All the labels and images, comma, labels dot to device. Next, train is equal to variables images dot comma 1 comma 28 by 28. So this means that there are 100 images in the batch, each with a single color channel, that is 1, that is grayscale, and each image is 28 by 28 pixels. And a labels is equal to variable labels. Then output is equal to model of train. Loss is equal to error of outputs comma labels. So here initialize, next is to initializing a gradient. For that, let's use optimizer dot 0 grade. So what we are doing is here initializing a gradient as 0, so there is no mixing of gradient among the batches. Then so next step is propagating the error backward. So we are giving loss dot backward and then optimizing the parameters, optimizer dot step, then count plus equal 1. It also means count is equal to count plus 1 if not count percentage 50. So it's same as if count percent 50 is equal to 0. So total equal to 0, correct is equal to 0, and then testing the model. For that, we'll take for images comma labels in test loader images comma labels is equal to images dot to device. Again, moving out, moving to the device, comma labels dot to device. Label list dot append labels. Test is equal to variable images dot view of 100, 1, 28, 28. Then outputs is equal to model test prediction is equal to torch dot max outputs, 1 of 1.2 device. Prediction list dot append prediction correct plus equal to predictions is equal to labels dot sum plus equal length of labels. Accuracy is equal to correct into 100 divided by total. Loss list dot append dot data. Iteration list dot append count. Then accuracy list dot append accuracy. If not, count percentage 500 print iteration loss accuracy dot format of count, loss dot data, accuracy. In the next step, let's visualize loss and accuracy with iterations. So plot iteration list, loss list. Plot plt dot x label mentioning number of iteration. Then plt plot dot y label x and y. In place of y we are giving loss, and plot, now we are supposed to give title for the graph. Title, it should be, first let's do iteration versus loss, next iteration versus accuracy. So for that, let's give iteration versus loss, and then plot, finally plot dot show. Wait for it to run. So let's run it. So as you can see, we got iteration versus loss graph, and here also even this piece of code is executed, and here we got the output iteration 500 loss and accuracy percentage we got. So we got the highest accuracy is 92%. Next, so now let's plot for iteration versus accuracy. For that, plt dot plot plot iteration comma accuracy list, then give plt dot x label. So x label will be our number of accuracy. Then plot for y label, and here will be the accuracy. Then plot the title. Our title will be iteration versus accuracy. Finally, plot the show, that is image. Here, give iteration list. Okay, and here we got the output. So when you compare this, here we have 500 to 3000 iterations, right? So here you can see from 500 to 3000 we have, and then loss, when we take the last iteration, you can see here the loss is 0.24. So when you can see here, the loss that is 0.24. So here, almost here it will be like 0.24. So then what we have, accuracy is 92. So you can see here accuracy 92. 92 is somewhere here. So you can see accuracy is 92. So the same way it's showing all the iteration, loss and accuracy of the label. Check the first also. So suppose take iteration 1500. So somewhere here 1500. The loss is 0.25, right? So loss we will check in this graph, iteration versus loss. So it was 0.25. So 0.25 will be somewhere here. So you can see here 0.25, and then okay, here 0.25, and then accuracy is 90. So yeah, this point is the 90. So this is how it is giving us iteration versus loss and iteration versus accuracy plotting. And in the next step, So now we will examine the accuracy in each fashion MNIST dataset class. So for that, class underscore correct is equal to 0.4 underscore in range of 10. Then total underscore in range of 10 with torch dot number of grade for images comma labels in test loader. Images comma labels is equal to images dot to device comma labels dot to device. Then say test is equal to variables of images, then outputs is equal to model of test. Then we give predicted is equal to torch dot max of outputs of 1 C equal to is equal to dot squeeze for I in range of 100. Then give label is equal to labels of I. Then class underscore correct of label plus or equal to C of I dot item and total underscore correct of label less or equal to 1. For I in range of 10, print accuracy of column dot to F of percent then give dot format output underscore label of I. Then class I into 100 divided by total correct. So now run it. So as you can see the output, each label accuracy is checked. So we got the accuracy of each and every label, that is t-shirt, trouser, pullover, dress, coat, sandal, shirt, sneaker, bag and ankle boot. And the accuracy of ankle boot is 98.20%. So this is my deep learning implementation in the fashion MNIST dataset using Pytorch, and I got 98.20% on the test. And to improve it, modify the layer architecture or parameters. And with that, we come to the end of this video on Pytorch tutorial. If you like this video, share it with your friends. Before I sign off, make sure you subscribe to our channel and hit the bell icon to get all the updates. We'll be back with more such interesting videos. Until then, keep learning and stay tuned to Simplilearn.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.